my name is Muyoluwa Adeyemi, and I'll be talking about how we can leverage the ML Kit to build smarter apps on Android. So a brief history, machine learning started from the computer, but emerging trend shows that the modern mobile phones of these days have enough capacity to process as much as traditional computers can. And our phones and tablets are now powerful enough to run software that can learn and interact in real time. ML is helping us build smarter apps. Example is the Google Apps prediction for the next apps you are likely to use, and a mobile app which solves the world's biggest problem, finding the perfect emoji. A lot of SDKs exist on mobile that help run machine learning on mobile devices. Some of them include software development kits developed by popular companies, Amazon, Intel, Microsoft, and we even once had the Mobile Vision API created by Google. Those were released 2 years ago, and they had 3 core functionalities: to detect faces, to scan barcodes, and to detect text. The Mobile Vision APIs have evolved into the Firebase ML Kit. And according to the official Mobile Vision API website, the Mobile Vision API is now a part of the ML Kit and will no longer be supported. So all the new functionalities are now going to be released via ML Kit. So if you have any projects using the Mobile Vision API in production, then start making plans to migrate them to the ML Kit. The ML Kit enables Android developers build smarter apps, like apps utilizing machine learning. So let's dive a bit into what all that is and how the ML Kit can help us achieve our goals. So machine learning, defined very simply, is how we get computers to learn by feeding them a lot of data. That's a simple definition, but it kind of gives us a general idea of what we are up to. We build a sample model. We build a model with sample input, feed it to the computer, and then we have the ability to improve or retrain that model over time, hence improving the accuracy and the learning capacity of the computer. This can be easy or difficult, depending on whether or not you know how to build models or if you have enough data to train that model with. And this is exactly where the ML Kit comes in. It contains pre-built models for some use cases we are going to see in a couple of slides. And then you don't need to worry. If you have no machine learning knowledge, you don't need to worry about building models or training them or all of that stuff. All of that is abstracted and hidden from you. You also don't need to worry about optimizing those models to run on mobile devices, because that's also a very huge headache. All that has been handled with the ML Kit. The best part, you can use all that functionality out of the box just by importing it in your GLADLE file. Android developers here should know what I'm talking about. Okay, so the ML Kit reduces the barrier to entry for building smarter apps. That means anyone can get on board. So whether you're an ML beginner developer who's just fascinated by the idea of smart apps, or you're an advanced ML developer and the basic use cases the ML Kit offers doesn't cover your use case, there's something for everyone here. All the features from the Mobile Vision API have been ported over to the ML Kit. The APIs have been modified, but at its core, it's still the same functionality. And these APIs that are provided out of the box are called base APIs. And this means that you can use this without the need for a custom model. And apart from those 3, we also have 2 more. That's the image labeling and the landmark recognition. That's 2 more added to the ML Kit. And then there are even more features to be released very soon. Smart replies are seen in Gmail, where you type something and are seen in Gmail, and then high-density face contour addition to the face detection API. So unlike the Mobile Vision API, the ML Kit offers a lot more functionality by providing access to both on-device and cloud APIs. The on-device APIs process data locally, even when the device is offline. But if you need a higher level of accuracy, then you need to turn to the cloud-based APIs. These have some free quota and then some pricing plans, depending on your usage. And the cloud APIs allow us to take advantage of Google's infrastructure and takes all the processing off of the mobile device. So, okay, you're an advanced ML developer. What if you want to do more than detect text or detect barcodes or detect images? Yes, that's possible. It's possible to include your custom model in using the ML kit, and you can do this by building yours or retraining a model and then converting it into TensorFlow-like model and then passing that through the MLKit API. So, okay, so Firebase takes care of hosting your custom models and serving it into your application. At a Cloud Next 2017 talk, Yufeng Guo, and a developer advocate at Google, gave a talk about TensorFlow on Android, and he highlighted several pain points of developing machine learning on Android with TensorFlow. And it's interesting to see that the ML Kit now provides a solution to each of those problems he highlighted in that video. For the first concern, how to include the custom model in the app, you can either choose to do that locally or store it entirely or host it on Firebase. And this will determine whether it's available offline or not. If we choose the two options, then the app will use Firebase. The app will load the model from Firebase when it's online and then use the on-device model when it's offline. Next, you might have security concerns. How do you prevent other developers from copying your model, for example? So in practice, most models are application-specific. So this is like worrying about another developer disassembling your Android code. Like, how far can they go? But it's something you should still be aware of. What about conditions to download the model? Is it going to be carried out only over Wi-Fi? Do you want the device to be charging? Firebase provides us with a set of APIs which allow us to configure all the conditions with which this should be done. The available options are when the app is idle, when it's charging, or when it has Wi-Fi. And then Firebase automatically provides users with the latest version of our model if it's hosted on Firebase. So you don't have to, if you have an update, you don't have to make users download the new version of your app before they get your updates. Once it's hosted on Firebase, that takes care of automatically dispatching models. And then you can also use this to have like different test users for your models. Firebase handles all of that. Next, we're going to explore the base APIs and see all they offer. So one of the base APIs is the text recognition API, and it detects text in Latin-based languages, and it works in both image and videos. The API segment works by segmenting text into blocks, and then paragraphs, and then words and symbols. A block is like a set of text on the same page. If you have a page of text on if you have a set of text on a page, that's a block. If you have paragraphs, paragraphs apply as we know them, and then words also retain their meaning here, while symbols are the individual characters that make up a word. Text recognition is performed both on device, so this API is available both on device and on the cloud. Although if you use the cloud API, you have a higher chance of a higher level of accuracy, although it's not entirely free. I think the first 1,000 uses are free, and then you're billed after use. You're billed per use after that. All right, now I spoke a lot about the cloud APIs and the on-device APIs. I spoke about how the on-device API, the cloud APIs are more accurate than the on-device APIs. So we're going to have a pop quiz to see whether you've been following all along. If you look at the two images, which of them were detected? Can you detect which of them were detected on device or which of them were detected with the Cloud Vision APIs? What is A? A is device. Why? There are smart people in this room. So yes, the answer is A because, of course, since the on-device API does not have as much, okay, so it recognizes only Latin characters, so it doesn't know what an ampersand is and just groups it together since it assumes it's a word. And then the Cloud API is smart enough to know that that's a character on its own and then separate it from the other two words. Okay, the API also recognizes, okay, sorry, that's all about the text recognition API, and now we'll talk about the face recognition API. This detects human faces in images and videos, but it doesn't work for animals, as you can see. And then facial detection is not equal to recognition. So if you have a picture, the API knows there are 4 faces in this picture, but it doesn't know that this is Moe, or this is Luknan, or this is Femi. No, it can't do that. And the face detection API does not have cloud functionality, so all the processing happens on the device. So it recognizes not only faces that are fully turned to the camera, faces can be positioned at different angles, and the API will still recognize that. It also recognizes specific landmarks, such as the eyes and the nose, and it does that by assigning, the API assigns a number to each of those landmarks. Landmarks are like specific objects on the face. So if you run this, it might know, okay, it knows it's number 3, and then if you query the result returned from that, it just gives you the number corresponding to the landmark. So it detects the left and right ear, left and right eye, as you can see in the image. It detects the left, right, and bottom mouth. It can also detect expressions, so it's smart enough to know whether someone is smiling or frowning, or the degree to which your eyes are open. So you can tell whether your eye is open and whether your eye is closed. So if you have ever wondered how apps like Snapchat are built, this was built using the API. So since it recognizes landmarks, I could just do a few calculations to detect where my head is, and then position the flower crowns based on that. And then, yeah, the API works on skin colors. Like, naturally, I would care if because we've had cases of racial bias in APIs like this, and at least I tried it on it, and it worked on all 4 of us. That's Femi, me. Okay, everybody's a GD in that picture except me. Yeah, so next we'll talk about the barcode scanning API. And this detects barcodes in images. It works on the device too. There's no cloud API for this. You can pass different things, driver's licenses, allow people to connect to your Wi-Fi, or pass business cards with the API. So I randomly saw this badge on Twitter, and I was curious to know what was in it. So I used it as an example, and I was able to get that name below. That was the information in the badge. So it detects 1D barcodes. Those are numbers embedded in barcodes, usually depicted by lines, black lines in varying lengths with white spaces. It also detects 2D barcodes, so QR codes. You can use it for QR codes, and they look like squares, contain many individual dots, and can hold a wider range of information than the 1D barcode can hold. And just like the face detection API, it can detect multiple barcodes in one image. It can also detect them when they are upside down. The image label API, that's the newest one that is not part of the Mobile Vision API, but now part of the ML Kit. It detects objects based on the images found in them. But the interesting thing about this API is that it not just gives you the images, it also has context about the image. So this was taken at Lekki Conservation Center, and you can see, if you can see the screen, I'm not sure everyone can, you can see that it detects a chair, and it knows that it's about 0.89% confident of that result. It knows there's a bench there, and about 0.86, that's pretty high. It also knows that that's a spot visited for leisure, and it's also pretty confident about 0.8 is pretty high, so it's pretty confident about that too. Image labeling is available both on the device and on cloud. Recognition on the device is free and has over 400 labels, but recognition done on the cloud has a higher accuracy and has over 1,000 labels. The image label API supports different groups of labels. It can recognize people, babies, cars, boys. It can recognize activities, dancing, running. It can recognize vehicles, animals, plants, and even places. And then which each result returns the confidence level. So if it's like, I'm very certain this is a house, So I'm going to return a confidence level of 0.99. Then you are very certain that the image in the item in the picture is indeed a house. Lastly, we have the landmark recognition API, and this recognizes well-known landmarks in images, but it also works on the cloud. There are 1,000 free users available per month. This only works on the cloud. It's not available on device. There are 1,000 users available per month. And apart from the name of the API, we also get the entity ID and the coordinates of that landmark. So fun fact, if you try places like, if you upload a picture, maybe like the San Francisco Golden Gate Bridge, it gives you the results, gives you the coordinates of that bridge, and then gives you the confidence level. But of course, I always want to bring things home now, so I started taking pictures of popular places. I took pictures of popular places in Nigeria from Google and then started passing it in. And then image 1, 2, 3, up to 10, no result. Finally, I got this image recognized. That's the Zuma Rock in Abuja. All right, so we've talked about what these APIs can do, and very quickly I'm going to walk us through steps of how to get started with them, how to get started with using the APIs in your apps. Our first step is to connect the app to Firebase. This is important regardless of whether it's an on-device API or the cloud API you're using. And then we need to add the dependency to GLADLE file, ML Vision dependency. If you're using the image labeling API, you need an additional dependency to add to your build, the GLADLE file. So this section that was for both cloud and on-device. This section is only useful for on-device APIs if you're using only that. You need to add these lines, this metadata to your manifest file. This is because when the users install the app, there's an option to download all the base API models before they're actually needed, so that even if the user is offline, they can still use the MLKit functionality in the app. But if you don't do that, then it's going to try to connect at the point where it is used, and this might not provide a good experience if your users happen to be offline at that moment. That's the only thing for on-device. So if you're using the cloud APIs, there are other things to consider. So the news is only Blaze level projects on Firebase can use the Cloud Vision APIs. What that means is that if you are using the cloud APIs, you need to input your credit card details on Firebase, because there's a possibility you might use past your free quota and get charged. And you need to have your payment details there before that happens. So after upgrading to the Blaze plan, we enable the Cloud Vision API on Firebase. We have to do that online and search for the API library. So now that we know all the things to look out for when using on-device and cloud-based APIs, let's get to actually building an app. So while playing around, I found out that each of the APIs, though they are different, they follow a specific pattern. So once you can follow that for any of the base APIs you need to use, then you're ready to go. I'm going to talk about the face detection APIs only here, though, because we have 5 APIs and we can't cover that in this time. So the first thing to do, but for both on-device and cloud, is to expose functionality. So the base APIs expose functionality to us with detectors, both for on-device and cloud. This can then be configured on all the options the API provides to give us more specific results. So let's walk through the process of doing that now. Here we have the FirebaseVisionFaceDetectorOptions, and we're going to populate this. So here we set the mode type. This will indicate whether we want accurate or fast mode. Fast mode is usually fast, but the accurate is less. The accurate mode is slower, but returns a more detailed result. So we talked about the landmarks on the faces, right? This is where you configure that. So you can either detect all the landmarks, or you can detect a specific landmark, and you have options for that. But of course, if you're detecting all the landmarks, know that this is going to be slower than detecting just one of them. And then you can set classifications. That's whether the eye is open or not, whether the face is smiling or not. You can set the minimum face size. So you tell the API, give me faces that are larger than this size. You can do that. You can also track faces. So if you know apps like Snapchat that have stickers following you around when you move your face on the screen, that is also possible with the ML Kit. And then after specifying all these options, we call the build method, and our detector is ready for use. Next, we run the detector, and the options we configured in the previous slide, this is where we use them. So we get an instance of the Firebase Vision class, and then add the options to it to get the Vision Face Detector method. So here we are, for this talk, I assume we're dealing with static images and not images that move around in the camera. So we call the Firebase Vision image, and this API allows us to pass images to it in different formats. Here we choose the bitmap option, and this returns a Firebase Vision image object to us. Next, we call the detect in image method and pass in our Firebase Vision image instance. We also call the success and failure listeners, and if it's successful, it gets called by the you get results from the success listener. If not, you get from the failure listener. And then we retrieve the information, and here, this is where we make use of all the results. So if the result of detection is successful, we retrieve the information. So in this case, we retrieve a collection of faces, and then we can pass through each face and then perform whatever actions we want on it. So let's say you had a picture that had like 3 faces, then you're going to have 3 items in this collection. And then if you want to get, this is how to get specific methods. So you can do face.smiling probability, face.getLandmark, face.right eye open probability. This is how you use the data from each face. We can also specify what we want to happen if there is an error. And then you do something with the error message or something. And then with these basic steps, we've created a face, we've detected a face with the ML kit and retrieved data from it. But while the detectors for the other APIs are quite different, but the entire process of getting information is practically still the same, and this applies to both cloud and on-device APIs. Finally, we are going to explore the use of a custom model with MLKit. So this is for advanced ML developers who come and say, I want to have a smart app, yes, but I want to do more than detect faces or detect text or detect barcodes and landmarks. So this section is for you. So like I mentioned before, the ML Kit provides advanced ML developers an opportunity to use more than the pre-built models. But this works too if you're not a machine learning expert. If you're not an ML expert, but you happen to have a custom model that you want to use, you can still use that because we're expecting that you might not be the one who developed that model. So the ML Kit works only with TensorFlow-like models, and TensorFlow is an open source library created by Google, and it's used for machine learning applications such as neural networks, but it is not optimized for mobile devices. TensorFlow-like, however, is TensorFlow's lightweight solution for mobile and embedded devices. It enables on-device machine learning inference with low latency, and it has a small binary size because it's supposed to work on mobile devices. It also supports hardware acceleration with the Android Neural Networks API. But note that you don't have to know anything about TensorFlow or TensorFlow-like in order to include them in our application because the ML Kit abstracts all of that. So even if you want to use custom models and you don't know how to use TensorFlow or you don't know how to use TensorFlow-like, then you're still good. So let's walk through the process of including that in our app, and then we can have the model classify images for us. And for this section, we're going to use an already existing model called the mobile nets. Mobile nets are small models that were designed to meet a number of use cases. But for this case, we are using it for image classification. And then just as we saw with the base APIs, there are a couple of steps we need to follow. Our first step is to connect to Firebase as usual. Then we add the dependency to our build or Gradle file as usual. Then the important step is that we need to convert the TensorFlow model into TensorFlow-like format. And this is done using the TensorFlow-like optimizing converter. I know that's a handful to say. But we only do this. You only need to convert if you have a TensorFlow model that's not in the TensorFlow Lite format. Because only models with TensorFlow Lite formats run with the MLKit. So there are a couple of things to keep in mind when hosting custom models on Firebase, if you choose to do that, and we'll keep that in mind. First, we need to specify that we have an internet connection, since, of course, we're going to it's going to need to make a network request before that can happen. And then, if you are familiar with the Firebase dashboard, this is what it looks like. If you go to console.firebase.com, and then to the left, there's the MLKit option. And then, if you go to the top, you find options to upload your model. So once you do that, it will appear on the screen. You'll see the screen that's currently being displayed. And you can enter a name for your model, and if the name you use for your model online is what you use to identify it in the app. Now we'll walk through things to note when hosting on device. So for this, we need to copy the TensorFlow Lite model with the TF Lite extension and put that in our assets folder in Android Studio. That's in Android Studio. And then the file will be included in the app package and available to the MLKit as an asset. We also need to, if you are using an app with mobile net, I think you also need to have a label list. So what that means is basically like you've customized your model to recognize certain things, but we need the list of things it needs to recognize. So say you've trained your model to recognize a cat and a dog. In your label list, you need to have 2 items there, a cat and a dog. And then when you get your results, all you get is the degree of confidence in the image that it's either a cat or a dog that's there. So if a cat is not there, you get data back, but it will be 0. And then if it's actually there, then you get a figure, depending on how confident it is that that object is actually in that image. And then we need to add this line to our build.gradle file, because the custom model will be memory mapped, and we need to specify that it shouldn't be compressed. So quick implementation. When the custom model is hosted on Firebase, we can set conditions for when it will be downloaded or uploaded. And if we're working with models hosted on Firebase, we create a FireCloudModelSource object, and then we set the name. Remember, the name was set on Firebase when we uploaded it. We'll set the same name here too, and then we'll specify download conditions. We'll specify initial download conditions and update conditions. For models hosted on the device, we create a Firebase local model source object and set it to either file path or asset path, depending on whether it's bundled with our app. Or you can also choose to, like, when your device is online, download the model from the server and then save it in your app. So that will be the file path, but if you manually added it to an asset folder, then it will be in the asset path. We use the Firebase Model Manager to register the sources we create, and this is done for either one of them, depending on the use case. So you can register local source and register the cloud source, or register both of them if you want. Then we have a Firebase Model Options object. These are very long names, with the names of the model hosted on cloud or both, and then use it to get an instance of the Firebase Model Interpreter. If you specify a cloud source model or a local model source, rather, the model interpreter would, so if you specify both of them, if the device is online, then it will use the cloud one, and then if it's offline, it uses the local one. We also need to set the format of the outputs and inputs in an array and include that in the Firebase Model Input-Output Options object. So we have our custom model, right? And we need to pass data into it. But the data needs to be of a specific format. In this case, we're using MobileNet, which deals with images. We're sending in an image with dimensions 224, 224. and then it's an array of 1. That explains the 1 at the beginning. Model dimensions 224, 224. And then it has the RGB format. That explains the 3 at the end. And then we also specify the output condition. So we're returning we're also returning an array of 1. And then we have the label list size. So it will use, returning the label list size. Remember the label list that contains all the different items that the model can recognize. So we take that, that list and then get the size and also return that too. So in this case, we are working with only 1 image at a time, and we need a way to tell that to the MLKit. And this image will be converted to a byte buffer and then sent in through the add method of the Firebase model input builder. Finally, we can run the interpreter after setting the input and the output format options. The results are returned through the success or failure listener, and this returns an array of probabilities as our input based on the label list we entered. This result can then be mapped to the labels we specified so that we know what probability each label has for each input. So if you have a map of maybe cat and dog, you get a result of arrays, probably 0.4 and 0. So if you get 0.4, that means it looks like there was something that resembled a cat in this picture, but I'm not really sure. And then for the dog, if you get 0, it means that it doesn't feel there was a dog in that picture. So finally, we run the interpreter after setting all of that, and we get our result. So in this case, I used a crossword puzzle as my input data, and then I got back the results, and I got back a list of, so for the mobile net, there was a list of 1,000 items, and I got back a list of 1,000 probabilities. But what you do in this case is just to, after mapping them, you find a way to map them to the original list, and then, of course, crossword puzzle is 1.0. You only get 1.0 probability when you are like very, really sure that that's what's in the image. And it's also accurate because the other items in the list were returned, the probabilities were 0. So yeah, the summary of all I've been saying for 40 minutes is MLKit makes it really easy for Android developers who are either beginner MLKit developers or really advanced ML developers to build smart apps. If there's one thing you take away from this session, then this should be it. So I didn't come up with this alone. I used a couple of resources. You should check out the talk by your friend Guo at CloudNext 17 about TensorFlow. I watched that. There was also the Google Code Labs on TensorFlow, TensorFlow Lite, and the MLKit. There was the MLKit official documentation, which I had to read like 3 times to like get it to work. And then I used a couple of sketches in the slides, and I got that for free from that website. Thank you very much. Do we have time for questions or no? Do we have time for questions? Yes? Okay. Please pass the mics to them. Please raise up your hand if you do.
Hi, my name is Taiwo.
Hi.
I want to ask, where can we get models, like custom models online for MLKit? Because I feel that there are a lot of models that we can use to make our apps smarter.
Okay, so the thing is, I don't know if there's a site that has, like, okay, here's a list of all the custom models you have.
Like maybe a link online, like GitHub for models, something like that.
Okay, so I don't know if there's a link to free. You can do a search, but I don't know if there's a link to free models. But I know that there's, I can't remember the name right now. There's one that recognizes digits, numbers.
Okay.
I can't remember that. But I'm sure if you do a search on that, you'd find information, yeah.
Okay. And is the learning curve for learning ML, how to use TensorFlow Lite, is the learning curve?
Well, it's a bit wonky because I'm not sure I know how to fully use TensorFlow Lite yet, but at least I know how to import the TensorFlow Lite model into MLKit and then use Kotlin and my Android dev knowledge to build smart apps, which is really the point of the MLKit because it's telling you, like, say, you really don't need to go through all of that. But the way I look at it is that, well, Android developers might not be required to build the models. So the way you have an app and then someone gives you APIs might be the way you have your app and then someone gives you model and you just need to ensure that it's in the TensorFlow Lite model. Okay. But it's also good if you can learn how to build it yourself.
Okay, awesome. Thank you.
Okay.
Hello, my name is Ibikunle Adeolua.
Hi.
Yes, in the demo code which you displayed to us, I noticed you used them hard-coded values for the dimensions of the
well,
image.
that's because I know I'm working with mobile nets and I'm working with an image and I know the kind of image I'm passing in. So it depends. For some, you might require, the values vary depending on what kind of model you're using.
Okay, let's assume I'm trying to send a model to the machine learning. I'm trying to send a batch image to the model.
A branch image?
Like a batch of images.
Okay. No, you can't. This process is only one at a time. Oh. I actually tried it, and I got an error.
Okay. Yeah, thank you.
But you can build your own model that accepts a batch of images. Okay. So it doesn't have to be this and that. I think that's the advantage of the custom model. Like, you can do whatever you want if you know how to build a model.
Hello.
Okay.
My name is Okwe. I just want to know how heavy is the library when you implement an Android app?
Okay, so I didn't measure it, so I can't really say. But the thing is that it's going to be really smaller than inputting your whole model into the app by yourself. It's going to be smaller than that. And then since it's specific, it's not like you are getting the whole of the Firebase APIs. It's specific Firebase-models-ML. I can't remember the entire name, but I don't think it should be too large. I didn't check it, so don't quote me anywhere. But I don't think it should be too large. All right, looks like that's all the questions we can take. Thank you very much.